All right, everybody, we are on math test number 4 out of the red book, question number 58. So go ahead and pause your video, find question number 58 out of math test number 4. Awesome, so you're on question number 58. We are hitting the end of the test. This is where the rubber meets the road. This is where we separate the students who are freaking out from the students who are just like running and gunning and feeling great about everything. This is the point. This is it. Question number 58. We're talking imaginary numbers. We're talking multiplying binomials. You kind of have it all in one awesome, simple, but not easy question. All right, so let's talk about this. We're looking for which one of the 5 answer choices is equivalent to this expression right here. So there's several things you need to be aware of, or I would say 2 specific things you need to be aware of to attack this problem. First, you've got to understand how to multiply binomials. Now, if you hear that phrase and you kind of faint, you probably are going to be skipping this question. So that's one thing you need to be familiar with, how to multiply binomials. All right? And the second thing you need to be familiar with is how to work with and evaluate imaginary numbers. Now, if you hear imaginary numbers and you think that you're dreaming, then again, probably not a question you're going to have much success on. So this would be a great example of one you would skip, move on, and work on the ones you will have a better chance on. But assuming you've multiplied binomials before, and assuming you've worked through imaginary numbers, we're going to do some quick review, and we're going to tackle this problem together. All right? So as we look at this, first thing you need to understand is a quick reminder of imaginary numbers. As we multiply this binomial by itself 3 times because it's being cubed, you're going to run into situations where you have I being the imaginary number I represents the square root of -1. That's a whole lesson that we're not going to get into. But there's a pattern when you have I multiplied by itself. I squared is always going to be -1. I cubed is going to be the opposite of I, or negative I. And I to the 4th is always going to be 1. And this pattern just continues and repeats. All right? So I to the 5th would be I to the 6th would be -1, I to the 7th, so on and so forth. That's really important for this problem. So that's the first kind of point of concern here. Second is actually multiplying this binomial. So what we're going to do, there are some shortcuts you could use here, but most students probably won't know those. So what we're going to do is we're going to do the simplest approach, which is simply to say this is the same thing as x minus 3i times x minus 3i times x minus 3i. Whenever you cube something, you're multiplying it by itself 3 times. So to do this, the simplest step would be what most of you know how to do is multiply 2 binomials by themselves, which is foiling. You've heard of this, first outside, inside, last. Okay, so we're going to do that with the first 2 binomials here. All right, so when you do this, x times x is x squared. All right, that's the first. We're starting to foil. Okay, x times -3i is the opposite of 3xi. All right, and -3i times x, because now we're on the inner terms, is again the same. And then you multiply -3i and -3i, and you get 9i squared. You have all of this still times the final binomial, because remember it was cubed. Okay. Now we're going to do a step of simplification before we do the multiplication. All right, so to take this, we have x squared. We can combine like terms. The opposite of 3xi minus 3xi is going to be -6xi. All right, combining like terms. Whenever you have an apple and an apple, you put them together, you have 2 apples. That's what's happening here. All right, and then plus 9i squared. Remember, over here, I told you before that I squared equals -1. So what is 9 times I squared? -9. All right, so now we're going to take that and multiply it by that original binomial again because we're cubing. So this is x minus 3i squared times x minus 3i. We keep moving forward, and now we take each term of this binomial, multiplying it by each term of this trinomial. We'll get there. Here we go. So x squared times x is x cubed. X squared times negative 3i is negative 3x squared I. All right, so that's those two terms multiplied together. Now we have this times this, so negative 6xi times x, which is negative 6x squared I. We take this, multiply it by this term. Negative 6xi times negative 3i is positive 18x I squared. Okay, at any point, feel free to pause this video, look at the board, and make sure what you've got is matching up. Okay, now we have the final two terms, the final two multiplications here. Negative 9 times x is negative 9x. Negative 9 times negative 3i is positive 27i. Now we need to do a simplification once again, bring these all in, combine like terms if possible, which is right now, this is kind of complicated. We gotta look, what simplifications can we do? One thing I like to see here, I'm gonna use a different color. I like to look and see that we have another I squared. I squared equals negative 1, so we're gonna do something with that. And we have two like terms right here that we can combine. So we're gonna do that. We're going to write this out as simplified as possible. There's only one x cubed, all right? Combine these. We have negative 9, so minus 9x squared I. Okay, 18 times x times I squared, negative 1. So that's actually 18x times negative 1, which is minus 18x minus 9x plus 27i. We're not done yet. We still have two more like terms. Negative 18x, negative 9x. We get, drum roll please. Let's keep going. 9x squared I minus 27x plus 27i. We cross our fingers, we look at the answer choices, and we hope that that is one of the answers. And as we look, we see it appears that F is the answer to this question.